Alright, so Jason, can I safely assume that you now know how to draw the graph of a parabola?
Yeah. You work out the y-intercept,
Okay, but now if
the x-intercept,
yeah,
and then you work out the axis of symmetry. With the formula, I just need to recap the formula for working out the axis of symmetry is b squared over 2a.
minus b over 2a.
Minus b over 2a. Okay, and then the value that you get from there, you substitute back into the equation, and then you have both your x and y value for the axis of symmetry, and then you can draw your parabola.
Well, the axis of symmetry is the x-coordinate of the turning point. So you just need to find the y-coordinate of the turning point as well.
Okay.
Okay, but now if you look at that equation on the board, can you draw that graph?
Well, I could try, but I don't know. I don't know if there's something with the 3, with the minus x cubed.
Yes, this is a third degree graph.
Okay.
This is not a parabola. So what you need to remember from the parabola that we've done is that first of all you need to find your y-intercept, and to do that you make x equals to 0, which will give you y is equal to minus 0 cubed plus 3 times 0 plus 2, so y is equal to 2. Pretty easy.
Yeah.
However, for your x-intercept, you need to make y equals to 0, which means you're going to end up with minus x cubed plus 3x plus 2 equals to 0, and now you don't have a trinomial that can be factorized. So how on earth are we going to find the values of x? Do you have any idea?
Well, can you maybe take an x out of, you take an x out of x cubed and 3x.
But there's no x at the 2 to take out.
2, yeah.
No.
Okay.
Have you done any questions on the remainder theorem yet?
Yeah, I used to be pretty good at the remainder theorem. I was actually going to ask for a lesson on that just to recap.
Okay, well here comes your lesson, because that's the only way you're going to factorize that equation, is by using the remainder theorem. Okay, so what you do is you decide on 6 possible factors. So you say it could be x plus 1, it could be x minus 1, it could be x plus 2, it could be x minus 2, it could be x plus 3, or it could be x minus 3. Alright, it could be any of those 6 values, and then you make them equal to 0 individually, so that you can solve for x in each case. So you're going to have x is equals to minus 1, x is equals to 1, x is equal to minus 2, x is equal to 2, x is equal to minus 3, or x is equal to positive 3. And you're going to take those values. That's what the remainder theorem, without going into too much depth at this stage with the remainder theorem.
Okay, Gary, sorry, Gary, can I just stop you?
And if you...
Gary, sorry, I just got to let my mother in the house. Sorry about that. Just hold on quick. Are we back now?
Okay, it's fine.
Sorry, Gary.
It's alright. Okay, Jason, what you do is you take those individual x values.
Okay.
Alright, and you feed them into the equation that we have there. And you obviously get numbers then, and when you add these numbers together and you get 0, then you know that original binomial will be a factor. So that's what we're going to be looking for. Which one gives us the first 0?
Okay.
So feeding minus 1 in there will give us minus 1 cubed plus 3 times by minus 1 plus 2. That will give me plus 1 minus 3 plus 2. And that will indeed actually give me 0.
Yeah, okay. Alright, so then that's the factor, yeah. So then that's the factor that you're going to use to divide into the equation.
Long divide.
Long divide, yeah.
Long division.
Yeah.
Alright, so for the long division, what we'll do then, because now we know what the first factor is, so we're quite happy. However, just before you start working on the long division, just divide right through by 0, by -1, to get x cubed minus 3x minus 2 is equal to 0. Okay, just to get rid of the minus in front.
Okay. Yeah.
And then we're going to have x cubed plus 0x squared minus 3x minus 2. Do you see what I've done there?
Okay, could you just write it as x squared, or do you have to put the 0 in front?
You have to put the 0 because in the original equation there is no x squared term. However, we need to keep place for the x squared in the long division.
Yeah.
So that's why we just multiply it by 0.
Okay. Alright, okay, now I
if you
have
write
no idea
just
what
x
you said.
squared, it's going to be counted as 1.
Sorry, Curry?
Right, and then we're going to have x plus 1 on that side. Sorry, Jason, what was that?
No problem. It's just, okay, can you just quickly explain how you got to the 0x squared? Please.
It's just a placeholder. I have to keep place for x squared, and there wasn't an x squared term in the original expression. I can't write plus x squared because then it will be counted as 1 x squared, which it isn't. It wasn't there to begin with. It wasn't there. So that's why I'm multiplying by 0, because I'm keeping the place for the x squared, but I'm actually having a 0 value.
Okay.
Okay, now you just need to observe carefully. To do the long division, there we have the factor, alright, the one that we found to be the first factor. We've got that now.
Yeah.
Alright? And then what we do is we take the x, just the x, and you divide it into the first term. So what is x cubed divided by x?
X squared.
Alright, and then you multiply that x squared with both of those terms. So you'll get x cubed back plus x squared. Yeah. And then this process I'm going to tell you now.
And then you subtract.
You draw a line and you change the signs. Don't say subtract, rather say change signs.
Okay.
Add. Okay, it comes down to the same thing, but rather keep this rhyme in your head of changing signs and adding. So that will be 0, and that will give me minus x squared.
And then you bring down.
Well, no, we don't have to bring down. The process starts all over again. You can bring down, there's nothing wrong with it, but you don't have to. Now the process starts all over again. You say x goes into minus x squared how many times?
What? Okay. Well, you'd end up with minus x, wouldn't you?
X goes into minus x squared. So, sorry?
You'd end up with minus x.
Correct. Minus x, and then the process repeats itself.
So,
multiplying the x minus x with both of those terms will give you the minus x squared back. Minus x there. Draw a line and change signs. Okay.
Okay. Draw a line and change signs.
That will give you 0.
I need to remember that.
That will give you minus 2x.
Okay.
Now the process starts all over
and
again.
Then
x goes into minus 2x how many times?
You'll end up with minus 2.
Okay, and then you multiply the minus 2 with both terms, and you'll get the minus 2x back. Minus 2, draw a line, change the signs, and when you add, you'll get 0.
And then the equation on top there, x squared minus x minus 2 is your actual equation.
Well, we'll get to that now. I just want to tell you there, those two zeros confirm each other.